Hello, my name is Antti Komulainen. I'm a service specialist at Raute, and this presentation is about creating value with data. We're going to begin with the upper level theme, what is data-driven production, then going into the details, what are the true benefits of data, and then in the end we're going to look also a little bit Raute solutions on this area. So what is data-driven production? It can mean a lot of things, even if we focus just on veneer-based products production. Chances are you are already being data-driven. So if you have order book to follow and your end products have certain quality requirements, which you are then measuring and following up during the process to meet those targets, then you are being data-driven. So obviously that is nothing new, it's been there for ages. But what has changed recent years is of course the amount of data. What can be measured and how easily it can be done, it's incredible today, and that has caused the amount of data to explode. However, I would say a bigger change in our industry already took place 20 years ago. So that's when the first automatic data collection systems were introduced. And some early adopters have been collecting data systematically ever since for a couple decades. Of course, there's a lot of development happening during that time. Data storage is not an issue. Computing power is today enables a lot of new things and a lot of new ways how to look at the data. Then, if you look at the big picture when it comes to data-driven production, of course, most of the data is generated at the mill. In order to truly get the benefits of a high-quality data collection system at the mill, you need to understand also the raw material and the end product requirements. So with the raw material, there are the general properties of wood species, some more suitable for veneer-based products than others, and some players are already focusing a lot on the regional harvesting data. So where the wood is actually coming from has surprisingly big effect how it runs through the production. And then on the other end, there's the end product requirements. So if you are exporting a lot, there are different standards in different market areas, and of course you need to meet those. Then R&D is always constant, a lot of structural use today, and the strength properties of veneer and plywood and LVL needs to be understood throughout. And of course, the total product mix of the mill needs to be feasible so that there is not too much byproduct or low price products. All in all, what I want to highlight here is that if you are able to enrich your production data with the raw material data and the end product requirements, there's possibilities to optimize the production much more further. Then, what are the true benefits of data? I'm going to begin with an example completely outside our industry just to get the mindset right. So this thing was a thing on the internet a couple of years back, and what started from a tweet, an employee of Autodesk company took the idea a bit further. You can see here 12 graphs with each having data points forming quite recognizable patterns. You can see circles and stars and whatever. But the interesting thing is that for all these charts, the hard numbers, the statistical properties are exactly the same. So the mean, standard deviation and correlation are exactly the same. And the funny thing was, and what the internet loved, is that you can also, with the data points, you can also get a very clear dinosaur on the chart and still have the same statistical properties. If you want to learn more about this, you can just Google Datasaurus. But why I wanted to bring this up, this is example how you cannot rely on just one or two KPIs. There can be a lot of happening behind those numbers. And of course, this is an extreme example of the importance of the data visualization. Then let's move closer to our industry and look at incoming blocks at peeling line. So here are two data sets. Let's just call them a pink one and a blue one. And on the x-axis we have the block diameter growing from left to right, and x-axis we have the count of blocks. So we can see how much there is middle-sized blocks and how much bigger and how much smaller blocks. In both cases, the average diameter is the same. Also the block count is the same, and the mode, the peak of the distribution is the same. But which one is better? Which one would you choose? I think I know what you think I'm thinking, but let's still go through a couple of those basic things. So with the bigger blocks, there is more phase veneer, which is always crucial. With the bigger blocks, there is also typically better yield. On the other hand, sometimes bigger blocks may come with a soft core and you are not able to use all that material. Then smaller blocks, if we simplify things, those are pretty much the opposite. Also with the smaller blocks, capacity may become an issue because smaller blocks may reduce the capacity of your peeling line. So there are definitely some pros and definitely some cons with the wider distribution. So somehow the pink one seems like a safer option. However, there is a catch. And this is how we often look at things, just by what's the average diameter of monthly basis or yearly basis. But the diameter, and we are not even looking at the distributions like this. But the diameter behaves a lot differently than the volume of the wood. So instead of diameter, if we take the radius and calculate the area of the block end, and then we can also calculate the volume. When diameter grows linearly, the area and volume grows non-linear, and that puts much more weight on the bigger blocks. And actually in this case, with the blue sample, there is more solid wood in it. And like mentioned, bigger blocks have also better yield, so that puts also even more weight on the bigger blocks and amplifies that effect, as well as you can get more phase veneer from the bigger blocks. Of course, that shows in the log price as well, so you need to pay more for such blocks. Of course, these things are not new as such, but there can be these little changes happening in the background which are easy to not notice. And earlier you can detect those, the better. Without proper data collection system, that's nearly impossible. With the good data collection system, you still need to pay attention to this. What I have done past couple of years, I have also gone through hundreds of millions these type of blocks with dozens of measurements each. And together with our customers in different development projects, we've been able to identify these small changes early on and actually achieve quite significant results. And this is already high-performing mills and high-performing production lines, and what I mean by significant, that may be just 0.5%, but that's what makes the difference on the industrial scale. So these are some of the true benefits of data in addition to the real-time day-to-day reporting. Then let's look at Raute solutions. So would be easy to say the more data the better, but as you go further to the sea, the water gets deeper. And what I mean by that is that it becomes a full-time job to go through all the reports and all the data. And that's not the point. So when you have a high-quality data collection system in place, so instead of you need to do the manual measurements and type into Excel and build the reports, you should be able to just focus on the further analysis and follow-up. But if you go check the reports every day or twice a day, just in case to see if there's anything happened, that's where you spend all your days. So I want to highlight one of the good features of mill sites, which is the notifications. So the system will notify you when your attention is needed. So bluntly put, the less user needs to access the mill sites, the better. But of course you need to put some effort to get the system running, learn the reports and fine-tune the limits and so on, especially when it comes to grading data. Each mill is a little bit different and grading needs a little bit different. So there's a lot of ways to optimize using that data. Although there's very impressive things happening already today, it's eventual that most of these decisions and optimizations will be done by artificial intelligence in the future. And as the saying goes, your AI will be only as good as your data. And this brings us to the topic, why would you consider a data collection system like mill sites from original equipment manufacturer like Raute? When we have built the machines, designed the machines, we know what they are supposed to do, what are the different functions and features there. We have also the understanding how to build the data collection. When the data collection is deeply integrated to the PLC and the code execution there, we ensure that we have a very high quality data. When things are going okay, you need only the very basic reports for the follow-up. But you can also use the data for many other purposes. When it comes to, for example, scheduling maintenance activities, there's a lot of data you can use. However, even if you would have very advanced condition monitoring system in place, so you have bearing vibrations, temperatures, and these kind of things measured, that alone won't help too much. There will be 100% sure anomalies, some weird things and peaks in the condition monitoring data, but almost 100% of the cases there's very natural reason for those. If you have very basic cubics in, cubics out uptime from the production, that won't help. There are a couple more steps that you need in between. First one is, of course, you need the product dimensions. That alone tells a lot also when you look at condition monitoring data. In addition, we can have from the HMI panels all the parameters that are in use. If there are some offsets in use, speed increased or pressures decreased, all those have also effect for the sensor data in the condition monitoring. In addition, we can also apply the grading data, which then gives you filters enough so that you can make sense also of the condition monitoring data. You can optimize process step by process step, take those things very far, but you need to understand also the whole process. And as you can see here in this picture as well, we have links there between the lines, so it's an end-to-end process. Raute's experience delivering mill-wide solutions shows also here. So as we know how the whole process should go, our data collection system and reporting supports also that idea. So although there is very detailed specific measurements and data for each process step, we have also uniform and generic data for all the production lines. So then you can have a real big picture and transparency throughout the mill, same numbers with same kind of reports. And that makes your life much easier. I have one more example before we wrap this topic. So when it comes to being data-driven, most important thing is to start. From the day one, you will get very high quality data and real-time data, what's going on in the production. And then when you have 1 month, 2 months in, you start to build the statistical base on top of which you can build more advanced analysis. You see how good the good days are and how bad the bad days are, what makes good days good, and how you can minimize the difference. And uniform the operation practices between operators and also between different production lines. And then when the landmark of first year hits, then you can also see the seasonal changes. So in the plywood making, there's surprisingly many processes where cold winter or hot summer makes quite big difference or effect to the production. So when you have accurate data to back up you in your strategic actions to steer through the following years, that's where the high quality data collection system pays off. Although you cannot control the weather with the data collection system, you can still minimize the unwanted effects of the seasonal changes. So to conclude, what data-driven approach gives you? You will have less byproduct, lower energy consumption, lower glue consumption, safer working environments, better timing on maintenance, and stronger and better products. This was my part. Thank you very much for your attention. Now there's also a separate, more detailed presentation on mill sites. I highly recommend you to check that one out as well. Hope to see you soon. Thank you. Bye bye.